number 71. 71 says, for a person at rest, the velocity v of air flow through a respiratory cycle, the time from the beginning of one breath to the beginning of the next, is given by the equation v equal 0.85 sine, in parentheses we have pi t over 3, where t is the time in seconds. So v is the velocity, I guess, of the airflow. I guess this is like if you go to the doctor, if any of you have asthma and you do the airflow, the peak flow meter, have any of you ever done that? Or maybe they've done that with you? No. So you may have seen somebody do it, or maybe you've done it, but I bet this is what this is talking about, is how fast your airflow is going. So it says inhalation occurs when V is bigger than 0, and exhalation occurs when V is less than 0. So if we have a positive velocity, you're blowing out. A negative velocity, you're sucking air in, okay? So use a graphing utility to graph V. So it's a real little graph. Find the time for one full respiratory cycle. Now we might look here and be able to kind of guess at it from the calculator, but how would we find the time for a cycle? What's that called?
Period.
A period. So the period is, how do I find it?
It has something to do with, no.
It's
2
pi over b, and b is the b is this number in front of the variable after sine, and so here my b is going to be pi divided by 3. T is like the x, okay? So that's going to be 2 pi divided by pi over 3. And to do the math a little easier, you might want to make the top a fraction. Put 2 pi over 1 and multiply by the reciprocal of the bottom fraction, right? And that might make it a little easier to think about. Okay, so if we do that, we can see that our pi's are going to cancel out, and we're going to get 2 times 3 is 6. So it takes a whole 6 seconds to, is that right? I guess so, to repeat it. I guess that's breathing in and breathing out. That seems awfully long to me. Let's see, let's all try. So if you do the math on the problem, it is 6 seconds. Some of you may be breathing faster or really slower, but so that's just what in the problem, what we're getting. So how many cycles is that per minute? Is that anything we're going to find in the equation? No. How are we going to find cycles per minute? Yeah, 60 seconds divided by 6. So that would be what, 10? So 10 cycles per minute. Okay. 10 cycles per minute. And then the D part, this model is for a person at rest. Okay, so that would explain why they're breathing so slow. How might the model change for a person who is exercising?
Just increase it to elevation.
Yeah, we could say according to if we're using the language of the function we've got here, the period would decrease and the cycles per minute would increase, something like that. I'm going to put that up here just so we can stay on the same thing. The period would decrease just because they're breathing faster, so cycles per minute increase. Okay, so that's all you're doing on a lot of these word problems, and notice they had us look at it on a calculator. Did we use the calculator for anything after we looked at it? And it's almost just like they wanted us to look at the graph, but they didn't really ask us to do anything with it. Now, we could have gone and found the zeros or something and traced, maybe found the zeros. It was easier to me to just pick the numbers out of the equation than it would have been to go try to use the calculator to find those maybe the x-intercepts where something started and something ended. Anyway, so you can use your calculator if you want to, but sometimes doing it by hand's faster. The next odd you have to do. I thought I changed that to black, but it didn't stick. Okay, so 73 says you're riding a Ferris wheel. Your height h in feet above the ground. Let me try that again. That didn't come out right. Your height h in feet above the ground at any time t in seconds can be modeled by h equal 25 sine pi over 15 times t minus 75 plus 30. Wow, this has got lots of stuff on it. maybe it would be nice for us to come in, since it's got so much stuff in it, and label it A sine. Okay, now here's something tricky they do. If they haven't they factored out the B here?
Yeah.
Because they've got pi over 15, and then in parentheses they've got t minus 75. How is that going to affect my horizontal shift? Isn't this, we would think that this is my horizontal shift right here, 75. But is it really 75? I'd have to multiply it by the number out front, because they factored that out of both of those terms. So my horizontal shift is really going to be pi over 15 times 75. So if they ever do that, if they ever write the equation like that where they factor the number out front, remember, yeah, that's your B, and it's easy to see the B that way, but then it also affected what your C was. Okay, let's see what they ask us about this before we go try to find a bunch of stuff. They say the Ferris wheel turns for 135 seconds before it stops to let the first passengers off. So 135 seconds is, what do you think we would call that then? First passenger is on, they've gotten on, and then it's turning for 135 seconds and it stops. What does that sound like that would be?
That's the cycle.
The cycle, y'all think? I would think. Could it be multiple cycles? Do they just run it for that time and go around once, or do you think they let them go around more than once? We don't know. Let's see if we find, if they tell us anything. Use a graphing utility to graph the model. Oh, great. Okay, so by looking at the graph, we can tell it goes about 4.5 turns. So we looked at it on the calculator, which is what A asked us to do. And the B part says, what are the minimum and maximum heights above the ground? Well, we kind of talked about that already, didn't we? Normally it would be, sine would give us that 1. This is part B. We already talked about it, but I'll put it on the video and just reiterate what they're saying. Normally the high value would be 1 from sine. But we would have 25 times that 1 and then add 30. So the highest it gets is what, 55 feet off the ground? How would I calculate the lowest? That would be the maximum. What's the lowest sine gets? -1. So that's what, a lot of times you're doing that with these type problems. You're saying the highest would normally have been 1 and the lowest would be -1. And then I have to just take in, I don't really care so much about all that period stuff in there or the horizontal shifts. I just care about the, amplitude here from the question they ask. So it would be -25 plus 30. So the minimum would be 5 feet. So that means the very bottom of that big Ferris wheel is sitting about 5 feet off the ground, which makes sense if you think about loading people. They probably got some stairs where people walk up. We could find that on our calculator. We could go second, trace, and then we want to know the minimum, we could hit 3. And then we go down and we could just find the bottom one of those curves, and we hit a left-bound value, and then it tells us to give it a right-bound value, so we can go around one of those low curves and hit enter, and then hit enter, and we could check our answers, and y is 5. We were right. We thought about it correctly. If we want to check a maximum, we can go second trace. Maximum is 4 on our graphing calculator. So let's go check out one of the high points here. So we just need to take it up close to one of those maximums, and we go to the left of it, we hit enter. We go to the right of it, we hit enter. And let's see, it says that y is 55. That's what we figured out just by looking at the formula. So you can do it both on the calculator, or you can just look at the numbers. Usually the maximum, the minimum, if you just remember the highest sign gives us 1, the lowest is -1, and then just look for things like the amplitude and any vertical shifts. That'll kind of help you see your high and your low values on these things. So that's all you were doing here. They could have asked us a lot more questions about this. And the good thing about the word problems is they give us kind of like, how does this model something in real life? Anything that repeats, like a breath or a Ferris wheel or ocean waves, things like that, those are things that trig functions would model. So on 75, they're talking about how much of diesel fuel is used on a farm. And it's labeled by, it's, if you look at the equation that describes it, it's 30.3 plus 21.6 times, in parentheses, no, times sine. I need to get rid of that parentheses. Oh, I'll just put sine like that. After the sine, you need 2 pi t over 365. Why do you think that 365 might be in there?
A year.
Yeah, a year. Farmers, well, you would think they would use less diesel fuel during certain months of the year, like winter time. Well, I don't know, maybe they've got a crop that they're harvesting year round. Maybe they change their crops out. So T is time and days. T is 1 is January 1st, so T is 365 must be December 31st. So here are the questions they ask about it. What is the period of the model? The number in front of the sign here is your amplitude. Remember how they've rearranged this one. They're a little tricky. This is my 30.3 is my vertical shift. I'll put VS for vertical shift. The B part is the thing that comes right in front of your variable that I circled there. That's B. This is my amplitude A over here. So if I want to find this, it's 2 pi divide, and I'm going to put 2 pi over 1 just so I'm setting it up where it'll be easier to simplify. And then I'm going to divide it by B, which is 2 pi over 365. What's your period going to be? 365. Well, that makes sense because that's a cycle. Well, a whole cycle of a year is 365. We probably could have thought that one through, but just it's kind of nice to see that the formula does work out for that. Let me stop it. B part is what is the average daily fuel consumption? Which term of the model did you use? Find the average. Can we find the highest value and the lowest value and divide by 2? Right? Wouldn't that be the average? Because if this is periodic, it's going to just repeat and it's going to look alike all the time, so the middle would give me the average. Because sometimes it's going to be more than others because they're going to be running tractors on some days, and then while it's growing, they might not run the tractors. So let's find the high and then the low. So if I want the average, I can say 51.9 plus 8.7, and that's going to be 60.6. And the average would be just to divide it by 2. And we get, what, 30.3.